I am Roberto Giuntini and I am Professor of Logic and Philosophy of Science at the University of Cagliari, Italy, or to be more precise, Sardinia, the enchanting island of Italy. So I teach Logic and Philosophy of Science. My main topics concern the applications of logic and philosophy to particular sciences, in particular to quantum mechanics. And there is a strong connection between quantum mechanics and philosophy, especially logic, because the first revolution of quantum mechanics taught us that we have to shift to new paradigms from a conceptual point of view, because microparticles have to have counterintuitive properties, being here and being at the same time here and there. So what is impossible for a classical particle? If we take for a tennis ball, you cannot say that tennis ball is here at the same time is there. And it is what happens in microphysics. A particle may be here at the same time and with a certain probability, and there with a certain probability there. This philosophy in these fields concern the conceptual foundations of matters, okay, of physics. So there are questions, for example, that have a real philosophical nature. For example, do particles really exist, or are they only mathematical objects? Because of course, we don't see waves, we don't see particles, we don't see photons. We have a mathematical construction. So what is we say in philosophy, the ontological status of these particles? We can see a tennis ball, but we cannot see a photon. We can only measure. In quantum mechanics, when you measure something, you destroy something. So the measurement in quantum mechanics has a fundamental role that is completely different in the classical mechanics. And this is a typical philosophical question. What is reality? Is reality something purely classical? Is exactly what we see every day? Or is something deeper? There is something different, and the behavior of these microparticles, I repeat, photons and so on, is different. So what is the real behavior of reality? Now we try to connect together with microhosts these philosophical ideas, for example, concerning machine learning and classification, the notion of classification. We try to tackle these questions by means of quantum formalism. So we have new algorithms based both on logical epistemological considerations and physical and computational considerations. And these new algorithms are there, they can be tested. We develop new algorithms, for example, for classifying biomedical images by means of these quantum algorithms. The first results are very promising. So these algorithms are better in terms of accuracy and speed up with respect to the very famous classical algorithms. The feeling of being part of a great community. This is what was one of the first feelings that I felt when I arrived here, that when you are TUM, when you are an IAS fellows, once you are forever. And this is the spirit of a collaboration that lasts for years and years. It's not just a parenthesis, my personal and scientific life, but it's something which is durable, which is permanent.